I will start in 1 minute, inshallah.
Okay.
Okay, let's start. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Dear colleagues, students, engineers, and all attendees from all around Jordan, I welcome you all to the 6th lecture of the research series organized by the Women Engineering Jordan section under my supervision. I am Dr. Yusra Obedat, an associate professor in the Electronics Engineering Department at Yarmouk University. I am currently the chair of Women Engineering Jordan section and the advisor of Women Engineering Yarmouk branch. I will begin our meeting today by introducing our distinguished speaker, Dr. Ahmed Ashara. Dr. Ahmed is an IEEE senior member. He was born in Irbid, Jordan. He received his PhD degree from Iowa State University, USA in May 2017. He is currently an assistant professor in the Electrical and Computer Engineering Department at Missouri University of Science and Technology. Dr. Ashara is the founder and the director of the Optimization and Intelligent Wireless System Laboratory, OS Lab, at Missouri S&T, where they create, develop, design, and build smart engineering technologies that optimize the available resources for the next generation of wireless and geospatial systems. His current research interests include smart city, wireless sensors, unmanned vehicles and satellite communications, edge computing, optical sensing and communications, reconfigurable intelligent surfaces, and green communication. Since 2021, he has been on the editorial board of the IEEE Wireless Communication Letters and the Frontiers in Communications and Networks Journal. His presentation title for today is Advancing Smart Cities Through LiDA Technology, Challenges and Opportunities. Dr. Ahmed, you are welcome with us today as a distinguished speaker in our research series. Thanks for your participation with us. I invite you now to begin your lecture. Please go ahead, the mic is yours.
Thank you very much, Dr. Yusra, for the introduction. Thank you also, Dr. Isra, for the invitation. It's my pleasure to be here and presenting advancing smart cities through LiDAR technology. So I'll talk about challenges, opportunities, and also current projects at my lab. So before that, I will start about overview of current projects in my lab. And then I will move to the LiDAR technology. I will start maybe spending long introduction about LiDAR, and then talking about specifications, why LiDAR is important, and how to process the LiDAR. And I will end this presentation by showing some challenges and also current projects in the lab. So the focus of my lab is wireless technology. And actually, when we talk about wireless these days, we talk about 6G or 5G plus or 6G. And one of the projects that I'm interested in is wireless localization. As you may know, like if we talk about like 6G technology, there are like two issues they are looking for, especially for the high frequency bands. They have the problem with the penetration loss. They have higher penetration loss and also short range of these like higher wireless bands. Therefore, we try to propose using RIS, stands for Reconfigurable Intelligent Services, in order to solve these two issues. Also, I'm interested in visible light communication, or commercially known as Li-Fi. It's not a replacement of Wi-Fi, but rather try to enhance the indoor connectivity. And by trying to modulate the light and sending the data over the regular LEDs or regular lights. Also, I'm interested in global connectivity, integrating satellite communication with high altitude platforms, UAVs, and terrestrial network for extending the coverage of the internet around the globe. And on top of that, I'm working on green cellular networks. So now I'm looking for an efficient cellular energy solutions. Now, one of the interesting projects that I work in the lab is LiDAR. And LiDAR stands for light detection and ranging, which is like a remote sensing technology that utilizes laser in order to create 3D mapping. And how this works, you can look to this figure. LiDAR start emitting laser pulses toward a certain object in order to create this 3D mapping, and then try to measure the reflected lights. By measuring the reflected lights, LiDAR will know the location and also the shape of the certain objects. And LiDAR, the output data of the LiDAR is point cloud data, as you can see, as if like kind of a dots, similar to this figure. I'll show you maybe next slide. This slide, a better figure output of the LiDAR. You can see here like a LiDAR output figure that includes a human, that's trees, this is a car, tree, buildings, and so on. So generally speaking, we have the output component of the LiDAR or output of the data, XYZ, which is the location of the object, the scanned object, and L here is the reflectivity, or we call it light intensity. And this is very important, and we are going to talk about this later in the slides. But let me first now talking about the LiDAR itself, the sensor itself. We use LiDAR sensor. And this is like a very general figure of a LiDAR components. I know like some advancement now for solid state LiDAR and so on, but still this is like very basic figure to look about. First, we have the laser source. Here, again, it's like laser technology. So we have this laser source, and then we have a tilting mirror. And this tilting mirror is sending this laser source towards a certain object with a certain angles. Also, we have a servo motor. This servo motor will help this tilting mirror to rotate in order to cover a wider area. And finally, we have a very important component, which is the optical rotary encoder. And this one will tell you exactly this laser beam coming from which XYZ. So it will tell you exactly the distance and also the location of each object. Now, let me talk about some certain specifications of the LiDAR. You know, if you are interested to buy a LiDAR, then you have to look to certain specifications, similar to the computer. If you are interested to buy a computer, you have to look to the RAM, memory, you have to look to the speed, GPUs, you have to look the cores, and so on. So similar to this, I mean, one of the components here in LiDAR is the mirror. And actually, the mirror design itself will give you a different scanning patterns. Just simply, if you have like this, integrate this LiDAR with a UAV and try to scan a certain area, then the selection of the mirror will give you a different scanning pattern. And each scanning pattern will be depending on the application. So basically, if you want to select a certain mirror, you have to look to your application first in order to select the good component that can fit this application. Also, the wavelength. This is another important component. The LiDAR in the market, mainly they have two wavelengths, 905 nanometer and 1550 nanometer. And each wavelength has different different like specifications, like it can be used for the 905 for higher resolution, precision, higher speed, and so on, while the 1550 can be used for longer range, and it is good also for poor weather conditions. Also, it's worth mentioning that we have also some other LiDARs working around like 500 nanometer, and these LiDARs will be used to penetrate water. So there are also like some other LiDARs with different wavelengths in the market. One more specification is for the channels, number of channels. and or number of beams that LiDAR can emit. And actually, as you have like more channels, this means like you have more resolution. So we look to the channels, and also we look to the point of view or angle of view, field of view angle. And this is important because, you know, if you need like a precise or you need like very accurate figure or output of the LiDAR data, then basically you need to make sure that you have the correct angle, and you have to make sure that you have correct number of channels that you need. So why we are interested in LiDAR? You know, we have like many specifications, different things to use a LiDAR. Why LiDAR? Why we are interested in LiDAR? One of the important things and interesting thing is illumination. LiDAR can work perfectly during the light or night. So you will get like exactly the same output data, because this is like the source is from the LiDAR itself. Compared to the camera, if you look to C and D here figure, that you can see this is like a camera cannot like work perfectly at night. I know like there's some night vision cameras on the market now, but still it comes with its own problems and issues. So this is like my student. We did this testing in my lab, and we can see from here that the LiDAR is like doing much better job in the illuminations compared to the regular camera. So I'll keep comparing this with a regular camera, justifying why we are interested in the LiDAR. Optical illusion, also like optical illusion is like a bigger problem in the 2D camera. But with LiDAR, because this is like a point cloud data, so basically we don't have this problem, or we have this like a less problem than the camera. Privacy. This is a very important and interesting point. LiDAR can protect the privacy compared to the camera, because you can see here that LiDAR, this is the raw data of the LiDAR, the original data of the LiDAR. It's a point cloud. This means this LiDAR will not show any personal identification information compared to the camera. So this is very interesting point of the LiDAR, and it will be interesting, you know, for me, even personally, I don't prefer to put camera inside the home. However, I don't mind to put a LiDAR inside the home, because LiDAR, if anyone like steal this data, will not be able to do anything with it in terms of my privacy, okay? Other things, LiDAR also can detect some unseen objects. Similar here, we did like also mini experiment in the lab. We just burn a paper, and we just like compare between a camera and LiDAR. You can see here in this figure that LiDAR can detect gases while camera cannot. This is a regular camera. I know, again, there are like some advanced cameras can get like some details about the gases, but compared to the regular camera, LiDAR can do much better job. Also, reflectivity, you know, as I mentioned before, LiDAR has X, Y, Z, which is like the location of each point cloud, plus L, which is the reflectivity or the light intensity. And this is very helpful in many applications, because by doing this, we will be able to differentiate between different materials. When I mean like different materials, this means the light intensity or the reflected light back to the LiDAR from different materials would be different. And this is why it can be shown in a different colors. Look to this figure again. You can see that this one, this may be like a light blue, while this one, this color is like dark blue, and so on. So this is very helpful in order to do like maybe segmentation later on. So one thing I also would like to mention that LiDAR or camera, like, you know, some cameras, they are biased towards the skin color. You know, the cameras can differentiate between, let's say, white skin color, or white skin, brown skin, and black skin color in terms of humans. However, LiDAR is a colorless. This means that it cannot differentiate between colors. And this is good, in order like to do like any like a human activity recognition or any human testing, because this will give you less bias compared to the camera, where camera can differentiate between like all these races or like color skins, while LiDAR cannot. So this is also an advantage to the LiDAR compared to the camera. Here I'm just summarizing the main advantages of using LiDAR versus camera or depth sensors. So before even I dig deeper into the LiDAR technology, let me just show you what we have here. What do we have here in the lab? So we have different LiDAR sensors in the lab, and you can see now we have it with different channels. 16, 32, 128, like most powerful one. This one, the Oster or zero, or also different angles or field of view angles, like mid 40 to the 15. Also, we have in the lab depth cameras, just for comparison between the LiDAR and depth cameras. We have some platforms that can carry LiDAR or do like some LiDAR related projects, like the UAV, a drone. We can install or integrate the LiDAR with the UAV, portable LiDAR carrier. This is like my student built that. And also we have some steering wheels and some other equipment that help us to for LiDAR simulations. And for sure, we need like some computationals. And here we have different computationals computers, high performance GPUs computers that we have. And finally, we have some AI and smart sensors, in addition to 3D printers that we needed for many, many projects in the lab. Now, let me move to the LiDAR applications. And there are many, many applications for LiDAR. And we talked about mainly in the previous slides about detection or classification, that we can detect if there is a chair, this is a human, airplane, and so on. However, there's also important things about segmentation. So we can also, because of this pointy cloud, we can also segment the objects. This means that we can differentiate between the airplane body, for example, with the wings and so on. And this is very important if we talk about like any transportation or other related applications. Also, one thing that I work with my group about skeleton identification. And LiDAR can generate very large amount of data. The OS 0, for example, that I have in my lab, generate around 2 million point cloud in each time instance. And this is like very huge data. So basically, with this LiDAR point cloud, we may be able to do a skeleton representation of the data and try to deal with less data than huge data. So all these applications, as you can see, it's like for static application, but also LiDAR can be helpful for tracking. So this will be like kind of a time series or a continuous LiDAR applications, like tracking cars, pedestrians, and so on. Also interaction between objects. So LiDAR may be like very useful even during the COVID time, where we need like to maintain a certain distance between humans. And also can be very helpful for prediction. Maybe combining LiDAR with Markov decision processes can be very helpful for prediction. Like this figure, you may detect a rock, detect a human, and then if the human is keep moving towards the rock, then there's possibilities of a falling. Now, however, LiDAR, again, because LiDAR has different output data compared to camera or other traditional capturing systems, it has some issues with the processing. So processing the LiDAR is not that straightforward camera for many reasons. We need to look for pre-processed. The process is data filtering that includes the region of interest, find the region of interest, or do after that some clustering techniques, sampling, or some hybrid approaches. Also, we do data labeling, and this is one of the critical things because there's no much available data for LiDAR in the market. Then basically data labeling is a big issue. And think about it. I mean, you just need to have, you have your own data, simulated or real data, and then you need to label the data. You need to label the arms, the heads, maybe inside the body, or you need to label the data. This is a human versus a chair and so on. And if you are going to do this manually, this will take a lot of time, a lot of time. So this is one of the big issues with the LiDAR as well. In addition to that, we do we need to do like data normalization, scaling, or having it like with a reference point, and also data augmentation, like rotation of the data. After doing pre-processing, we have to look to the learning stage or the processing stage. And there are many, many solutions in the literature, starting from the point-based solution, then something called voxel-based solution, or some combined fusion approach, and some other approaches. There are many, many approaches. And actually, we have to be careful when we pick up the solution. Because, for example, here, point-based solution will just consider the point by point. And as I mentioned, maybe you have like 2 million points. So you need to deal with the data as point by point and do the learning point by point, which is very expensive in terms of the complexity. However, voxelization can be very helpful in terms of, instead of looking point by point, we look, for example, cube by cube. And again, it will be like different ways. You're doing it like regular voxelization or super voxelization and so on. However, if you are doing it like cube by cube, you are losing some resolution, some information. So it's kind of a trade-off you need to think about. Are you going to do point by point or voxelization, voxel-based model, or even you look for a hybrid solution that contains point plus voxel solution. And there are some others, as I mentioned, long short-term memory, support vector machine, mainly about optimization. You just need to deal with some optimization techniques to do this kind of binary classification or non-binary classification, and also k-means clustering as well. So let me summarize, like spend maybe much time talking about the introduction, but let me summarize what we need to do for the LiDAR data. So first we have 3D LiDAR data. We need to do pre-processing, filtering, labeling, augmentation, normalization, and so on. And then we need to pick the learning model and even maybe sometimes modify the learning models. And not only that, if we consider some time series application, then you need to do tracking. You need to apply maybe Kalman filter or uncertain Kalman filter, some fusions after the learning model. Then you can get your outcome or your application, either segmentation, activity, trajectory, or track. Now, let me move to the challenges of this LiDAR technology. And maybe I mentioned this quickly in the previous slides. One of the big challenges in the LiDAR technology is the scarcity of the data. We don't have much available data here. So therefore, or even if we have, it will be like for just certain specific application. So therefore, somehow we are forced to work with simulators, not a real data, or digital twins. So in my lab, actually, we use simulators. And also, we are now collecting data. So we are trying also to collect a data as well, real-time data, using the sensors, the LiDAR sensors that we have in the lab. But for sure, simulators is needed in the system. The other thing is like processing the data. So LiDAR will generate very huge amount of data, and we need a processing mechanism to process all this huge data, especially if you are looking about real-time processing. This, we may end up with the need of mobile edge computing systems that can distribute all these like LiDAR loads into different computers in order to process the data much quicker. Since it's laser technology, you know, there is like some environmental effects like rain and so on, layer and fog or so on. Therefore, there are like several solutions that we also deal with. Either we do it like in software solutions, we consider these environmental effects as noise, or we look for the hardware solutions. So we look for frequency modulation or even change the wavelength. As I mentioned, there are like some LiDAR specifics for penetrating the water, which is like around 500 nanometers. So we have to figure out like some other solutions because of the environment effects. So what we are doing here in the lab, there are many projects that we are conducting here in the lab. And one of them is the human activity recognition, LiDAR-based human activity recognition. So try to understand the human actions using LiDAR technology. One other thing, project may be having this LiDAR for mapping. It can be either mapping from sky by integrating this LiDAR to a UAV and try to map, to do like 3D mapping from the sky, or even placing this LiDAR into the current infrastructure, road infrastructure, in order to do mapping for the cars or pedestrians in the road. And we are lucky here at Missouri S&T because we have experimental mine. And since we have this experimental mine, we get this advantage, and we also use LiDAR for air quality detection. I'm not saying that we are going to replace the air quality sensors, but LiDAR can enhance the air quality detection by having 3D mapping. So integrating LiDAR with air quality sensors will be very useful in terms of mapping the area inside the mine. So let me now quickly move to some details about some of the projects that we have here in the lab. So here I'm talking about the human activity recognition, and mainly we are focusing this LiDAR for senior wellness. And we are collaborating with some elderly homes and assisted living here in Missouri in order to install our LiDAR there and try to get a real data. So what we are doing here, there are many projects under this umbrella of a human activity recognition. So we first look for breathing monitoring. And also we look for gesture identification or body part segmentation. And also we have this experimental evaluation as phase 3. So let me just quickly move between these phases and just to give you an idea about what kind of project that we are doing related to the human activity recognition. Interestingly, we are using LiDAR to detect breaths of a human. And this is real data. It's not like a simulated data. So this is a real data. This is my student here trying to breathe, and we're trying after that, collecting the data, plotting the data in MATLAB. And this is like the chest, finding the chest, and try also to find these peaks, the breath peaks. By doing that, we were able to find the breaths of the human. Also, we can find the respiratory rate. We can find the breath depth, and also the times where the human is non-breathing or holding breath. So here's like the experiment that my student did. So we have like different angles of LiDAR versus a human, where the human facing LiDAR, human facing the back, or the LiDAR facing the back of the human, or with a certain angles, or in the sleeping positions. So we did all these like testing experiments, and we were be able to getting like very good results. So we apply data filtering first to filter the data, and because we are interested in the chest and trying to get like the chest movements. And we then, after that, trying to apply some moving filters, because now this data is kind of, a little bit ugly. We are not be able to deal with it. So we apply some moving filters, and then trying to find as I said, like the breathing recognition, the depth, or some other breathing parameters. So here is also, we try to evaluate our methodology using the accuracy as it's defined as the true positive plus true negative over the rest, and also the root mean square error. And we can see here that we will be able to get very good results, like up to 100% if it is like facing the LiDAR, and maybe if it is in the side, it's around 87% and 93% accuracy. The other part of this project is the patient gesture identification. And mainly here, maybe in this slide, I'm just focusing on the arms identification. Actually, we are doing body part segmentation and identification, but I did not include this in this presentation. So here we just like focus on the arms identification. So what we did is like, we don't have data. So this is one of the yearly like project that we have done here at Missouri S&T. So we use simulators. We use like a simulator called Beepot Simulator to generate data. And then we are trying to apply MLP to find some kind of body part segmentation. So what we did is getting certain scenario in the simulator. And the good thing about LiDAR that we can take this pointy cloud and put it in MATLAB. I'm from EE background, so I love to deal with MATLAB. So we just take that point cloud, we put it in MATLAB, and we apply region of interest filtering first. Then we applied some certain data rotation, followed by data labeling, and then we do like data shuffling and normalization in order to prepare our data. And then basically we apply some certain human geometry, like standard deviation for the human body parts. And we put all these to a neural network, MLP neural network, and then try to find a arm segmentation. And not only that, we also do sub-segmentation, because it's a point cloud, point by point. So it's easier now to find a date or a curve fitting. And based on the curve fitting, linear curve fitting, we found the slope. Once you get the slope, you can tell if this is like the arm, if you are dealing with the lower arm or the upper arm. Also, we were able to find if the arm is stretching forward or stretching backward. And here's like, we show that the confusion matrix, that we were able to get accuracy around 91% of this scenario to find just only the arms. As I mentioned, we are doing all body part segmentation, but this is kind of initial results, and we have more coming very soon. Now, the previous part, the body part segmentation, was based on simulated data. However, we are also working on getting real data. And this will be like one of the first data ever to find in the internet. So we are trying to have multiple LiDARs, multiple sensors, and try asked some actors, actually mainly my students now, but we'll try also to hire actors in order to do some certain movements that we need. So this is my lab, as you can see. We have these are the LiDAR. I think this is the ultra buck LiDAR that we used because of the short range. And also we add Connect, Microsoft Connect, which is like a depth camera for comparison. And this will can also like help us to give us like some more information about the skeleton. So we are trying to we are working on experimental data, and it will be available very soon. Here's like very sample, like 2 samples of the data. As you can see, like my student here again, the actor is like falling. As you see it, like this is like, I'm not sure if it's clear or not for you, but it's like the student here is like falling, while in this side, the student is leaning or like dizzy walking. So more coming. My second project, I know like time is limited, but I'm trying to move faster. My second project is to do like mapping from the sky, LiDAR from the sky. And we have 3 phases in this project. We look to the object detection, LiDAR data fusion, and then the backbone network. So we need to detect the objects in the ground, either car, bicycle, pedestrians. And then because we have multiple UAVs, we need to fuse this data between these UAVs. And finally, we need to transmit this data or transfer this data between UAVs in order to create a full map in each UAV. And even this, we need like to do some work by doing some certain optimization to find the best location of the LiDAR sensors. And as you can see here, we have some certain optimization problem that we need to solve, aiming to having less number of UAVs to cover a wider area. This is the objective function. This is our goal. However, we need to consider different parameters. And this is why this problem is a unique and is interesting comparing to other UAVs placement in the literature, where we need to consider the resolution of the UAVs, resolution of the LiDAR that integrated in the UAVs, and also we need to consider the coverage area. So we need the UAV not to go very high and not go very below. If it's like the UAV is like very low, then basically it will cover the area with a higher resolution, but we need multiple UAVs. We need maybe large number of UAVs. If the UAV is going high in high altitude, this means that we need less UAVs. However, the resolution will be very bad. So we are trying to optimize to find like kind of a solution in between in order to figure out these issues by solving this optimization problem. Then the second part is the data. Again, we don't have data now. We are integrating and we're trying to fly the UAV to get more data, but we use simulators. And we don't have data, we use simulators. And for the labeling, we use Label Cloud. It's well known. And also we do some object detection by doing it not point, not voxel, but rather it's kind of a combination between voxel-based and point-based. And then we do some data augmentation or Kalman filter for tracking. And finally, for the transferring data between UAVs, it's another optimization problem. However, this cannot be done with a regular optimization because we are interested in transferring the data in a real time. This means that the maps in each UAV should be a real-time map. And therefore, we're trying to do some learning. And here we use waveGAN. Maybe next slide will show you, like we use waveGAN in order to transfer this data in a real time. It's like kind of a learning techniques, kind of 2 neural networks are competing with each other in order to give better trajectory and better connection between these UAVs. Here are like some of the results that we published. You can see like this is kind of a road segment based on the road segments and we can, or road layout segments, we need to do like a different optimization problem that can cover this road layouts while satisfying all the constraints and all the limitations that we need. And we can see also here, this is R0, which is kind of a resolution that we require, and how the resolution will change the number of UAVs needed. So if you are looking for lower resolution, you need less number of UAVs. For higher resolution, you need like more UAVs. Here's also the tracking results that shows this is a UAV here. This is a human is moving, and we're trying to track the movement of the human. So we compare our proposed solution with an optimal, the ground truth optimal, and we are achieving very close to the optimal solution. This is for pedestrian, and also we're getting this for a cars. And here you can see here we were able to achieve around this is the average precision or accuracy around 89% for the point voxel without data augmentation, but with data augmentation, we'll be able to achieve 92% for cars and 90% for pedestrians. It's worth mentioning, as I said, like this is the fusion, LiDAR data fusion. Because we are now doing a mapping and we need to fuse from different LiDAR or from different UAVs. Then, for example, we use like different fusion techniques. One of them is like raw fusion, that this UAV, for example, will see like just only half of the track, and then the other UAV will see the other half of the track, and then try to raw data fusion in order to tell, okay, this is the track. Or we can use decision fusion, that maybe the first UAV will try to tell, okay, this is half a track. Then the other UAVs will tell this is half a track, and then try to combine them together in order to get like a track decision. So all these things we consider, we analyze, and in details in the papers. For transferring data between the UAVs, we use like the waveGAN technique that I explained to you, and we will be able to achieve very close performance in a real time compared to the optimal solution that require long time, maybe hours or days in order to get this performance. So we end up with something like this for the waveGAN path, but not only that, because you can see like this is like the path between the UAVs, as you can see here in this left side figure. However, like we have some errors here. So what we apply a beam search path and try to adjust these errors and try to find the best path between UAVs. Not sure I have maybe 5 minutes. I'll try to just quickly skip. We have another project that we integrate LiDAR with RIS. So I talked about reconfigurable intelligent services. It's kind of a smart reflectors to reflect the signal from the base station to the user and try to find the localization and so on. However, because I don't have time here, I'm just going to quickly.
I'm not sure if you're talking about our time or your time.
Yeah, both actually.
I open like the time for 2 hours actually, so you have
Oh,
1
really?
hour left.
Good. Okay, so I have then maybe 10 minutes
Okay.
or 15 minutes. So this is good.
Okay.
So basically here we just trying to have this LiDAR to assist the beam forming on one side and also to help with the RIS localization. As you can see here, we integrate LiDAR with beam forming base station in order to predict the beam forming and trying to send the data to each of these cars. This is like for the 5G technology or 6G technology, where you have short range, high frequency wavelengths, frequencies, and therefore you need to perform some certain beam forming towards certain objects. And you need to tell where is exactly the object there, so you can send the beam form the beam exactly to that object. So we use this for beam forming assisted, also for the RIS localization. So I'll just maybe skip quick the details that we have here for the channel model, how we use like kind of sparsity of the data in order to achieve this. And then again, we use simulators here. And then maybe move to the last project that I want to talk about. So here is, because we have a mine, experimental mine at Missouri S&T. So what we did is we did some data collection mainly, and just very basic processing of the data. So we tried to build this portable with my undergraduate students. So this was like undergraduate project, and they won the first award on senior design projects in the department twice. So this is like very good. I'm very proud of them. And we built this from scratch. So we were able to have this portable LiDAR device and then moved inside the mine and try to collect some data. As you can see here, we just be able to collect data as a map instead of just having values. So basically, LiDAR will assist the air quality sensors by even detect particles as small as 0.5. This is particular matter. So if you have like some experience in chemistry or something like that, maybe air quality. So this is like one of the famous particular matter 0.5. And we were able to detect up to that with a very cheap LiDAR. I think this is mid 40 or mid 15. So like a cheap LiDAR, we're able to get even very good accuracy. Maybe other thing that I need to mention before I conclude. I have many projects also in my lab, especially for undergraduate students. They come and join for some mini projects. We do fishing with UAVs, and actually this is almost done project. I mean, we integrate everything, and we try to connect the UAVs with not LiDAR, I think sonar sensor, and try to fish, like finding the fish inside the pool, swimming inside the like a pool or inside a lake, and then trying to just like having this kind of fishing tools down and try to catch the fish. And we did like some testing here. So we did some testing. Oh, okay. So we did some testing actually with my undergraduate students under using the swimming pool. I mean the university swimming pool, and we will be able to get some data that we use with the UAVs and try to fly the UAVs outside.
Yeah.
Okay. And some other interesting things, again, even if we use simulators for LiDAR, so this is for LiDAR, even if we use simulators for LiDAR, we need to have like some human interaction. And this is why we have kind of platforms or some equipment like steering wheels that we can control the cars, is like my students controlling the cars, and at the same time, we are collecting the LiDAR data. So this is, I think, Weebit simulator that we used. So the student is driving, and at the same time, we collect the data of this student. And actually, this is kind of, to match as much as possible with the maybe human driving, something like that, and instead of just depending on pure simulations. Also, we have some kind of mini projects. We have this kind of smart jetbots and try to program this jetbots to move in a certain direction. And we have a LiDAR here in order to detect this jetbots and try to maybe predict if there's a car or if there's like car accidents or if there's like obstacle here, something like that, then ask the jetbots to change the direction and so on. This is also like a very interesting project that can mimic somehow the real scenarios outside, but we can do it inside the lab. And here's some real data collection. We collect this data in front of the library. And as you can see, this is the protected privacy, but we can tell this is a human and so on. And this is also in front of our building. It's like, you know, cars, you can tell that there's cars coming here, and you can tell this is tree, this is a building, and so on. So this is kind of data that we are working on currently. So collecting the data and processing this LiDAR data. I think I'm done. So I would like to thank my graduate students for helping me preparing this presentation. You know, I try to get most of their works related to LiDAR. I know they are working on different projects as well, but I try to collect from them most of the works that's related to the LiDAR. So I'd like to thank them as well. And finally, this is my end of my presentation. So here is my lab website. Please go ahead there. If you have any question, you can just learn more and check all our papers, book chapters, and so on. And I'm now open for questions.
Thanks a lot, Dr. Ahmed. That was really informative, distinctive, and interesting, actually.
Thank you.
And rich with information. There's so many information, many projects there. So thanks a lot. That was a great contribution to our series, actually.
Thank you very much. For sure. I will be happy always to help.
Inshallah. Before I ask my questions, any questions to Dr. Ahmed? Please raise your hand or send your question by chat. Any questions?
If you allow me, please.
Yes.
Dr. Ahmed, الله يعطيك العافية. دكتورة سحر. Again, I'm going to say, as Dr. Yusra said, many thanks for this interesting presentation. But I want to ask you a question. I'm not sure if this is a naive question. My background is computer science, so I'm not an engineer. So you talked about the specifications for the LiDAR. Is there any specific or the number of LiDAR that I need to use it in indoor or outdoor?
Yes, this is a good question. And again, I'll show you here maybe some of the equipments. Okay. So basically, this is kind of the LiDAR that we have. And as I said, like before, that there are some LiDARs can be used for short range or long range. So for example, this one, the OSR 128 channels OS0. This one the range is for 10 meters only. 10 meters, 360 angle, it can rotate, and the range is up to 10 meters. Okay, from I think 0.5 meter to 10 meters. Okay, however, this Tele 15, it can be up to 250 meters, and similar to the box here, 250 meters. So it depends on this angle, on the angle itself, and depends on the number of points that you have, and also the mirrors that you have inside your LiDAR. So based on your application, you need to select the LiDAR, specific LiDAR. If it is like, let's say, for example, Tele 15 is like angle, the horizontal angle is 15 degrees. And it has, I think, 400, maybe 200 to 400 thousand points, point cloud. This means that all these 2,000 points cloud will be in this 15 angle. And this is why this one is a long range. Compare, for example, to mid 40 or to the OS0, where they have like OS0 360. This means that all these angles, I mean, it will cover like 360 angles. This means that all these channels will be distributed. And this is why it's a short range. So it depends on the specification.
Like very similar question, Dr. Ahmed. So you mean there is like different types of LiDARs? So sometimes can be used for wide range, sometimes can be used for very small range and short range.
Yeah.
So suppose that I want to do imaging for entire, like let's say a place or big area. So I need to use more than one LiDAR.
Now you can use more than one LiDAR, but again, it depends on the range.
That can do imaging for the entire area, or I have to use more than one LiDAR.
Now
it depends on the application. Sorry.
It depends. So if you use, for example, a building, if you're just doing like a building within maybe 100 meters, for example, and then you just need to get this building from certain angle, for example. Then you can use maybe the box here. Will be like very good fit because this is like up to 200 meter, 250 meters. So this will be good. And again, this precision or the accuracy or resolution will change over distance. If you are closer, you are better, most likely.
You have used like more than one unmanned vehicles for example, imaging a place that has a truck.
Yes.
So
Yeah.
this
For
will
that
be
one, we
expensive,
sorry.
right?
Sorry.
This will be very expensive if I want to do tracking for the whole street or big street, for example.
Yeah. So here's the thing. Now the question is, if you want to do it for streets, and you know this is a crowded area, this is a crowded area, and you need to do it for every time, all the time. So it's better not to put it on a UAV. Just put it on the infrastructure itself. If you think that, okay, I'm going to do it for a temporary application, like you have a marathon or something, it's happening. So it's maybe better to have it on a UAV, just for maybe few days and then just remove it. So it depends.
But tracking needs you to like fix the LiDAR somewhere in the infrastructure.
It can be fixed. It can be movable. It can be. So it either you move with the objects, or you can fix and you can see that the objects are moving. Actually, in the scenario that we did in the paper that my students did that, where is it? Maybe here. We fixed the
Breathing.
LiDARs.
Or breathing, yeah. Or
We
breathing.
fixed the LiDARs, and then we changed the LiDAR in its screen time. Let's go down. Yeah, here. So we fixed the LiDARs. Yeah. So we fixed the LiDAR, and the truck is moving. Okay. Or the cars are moving. But yes, you can do.
I assume there's at the sensor level there are some IMU or GPS on the LiDAR.
Yeah, we use there's the IMU, but we try to rely on the GPS on the UAV. So we have a GPS integrated on the UAV. So we are trying to rely on that.
Have a GPS. I think you need IMU if the like for example the object is moving, right?
For LiDAR, we don't need it because it's a pointy cloud and it will tell you for this time instant, this is the XYZ of the objects, of the point.
Just using GPS.
The next point, yeah, GPS will tell you just only the location as a reference point.
So suppose that I'm gonna just like place my LiDAR like on a helmet, when a person he is moving, just to image an area and like discover this place and take an idea about this place. So GPS is enough for the LiDAR to determine this image of the area?
No, you need, in this case, you may need IMU. In this case.
Right? If the object that carry LiDAR is moving, we need IMU, right?
I'm not saying that because this is precise mode. So you need, even if this UAV is moving, because we have a GPS and the signal will be good GPS for this UAV because it's like on the air. But if it's like in a helmet, I'm not sure about the GPS signal, the quality of the GPS signal, even if you have a GPS. So it's better to get IMU, I think. It's better to have IMU on a helmet.
One more question, if you allow me, Dr. Ahmed, have you used the LiDAR for traffic congestion? Because you said that we can install it on specific, let's say, traffic lights, with the traffic lights. So have you used or you have any project related with detecting traffic congestion by using LiDAR? Because I'm interested with this.
Yeah, actually, we have two projects. We did two projects, one already published. I did not mention it here. I'm sorry, I tried to squeeze everything that I have, but yeah, I forgot something. One of them that we used it, and we use like mobile edge computing for that. And but the other one is still working on it, and we just send it to publication. I think it's ICC, this ICC. We use simulators called Blender, and not just doing the traffic congestion monitoring, but also pedestrians, maybe like pedestrian with some unpredicted moving somehow like this. So we try also to do traffic congestion or number of cars, everything here in a certain traffic lights, but
Mhm.
also we look to the pedestrians' behaviors as well. So both. So we
And
send that for publication.
Like many
La-
questions in chat. A
last funny comment. Okay, the project related with fishing. It's kind of cheating. Okay, because fishing is like, you know, you need to sit and relax and wait for the fish to come to you. But so it's just funny comment. I like it.
You know, this is
Thank you,
my
Dr. Ahmed.
undergraduate. This is my undergraduate students. They did that, and we built everything. You can see here, maybe.
Yeah,
So
I
we
like it. Oh yeah,
so
thank you.
the fish, yeah, we just like flow the UAV like I think 100 meters somehow on the lake. So we did it. We did it like in the lake. So we flew it like 100 meter on the lake, and we just like send this kind of sensor the,
يعطيك ألف عافية دكتور. Very
to the
interesting.
to the
يعني
surface.
I
They
will
want to
look for your
surface.
research related with road traffic congestions. Thank you, Doctor. Thank you,
Sure, if
Dr.
you want, I
Yusra.
can send you the papers. I mean, if you just send me an email, I will send you like
I will. Oh,
that
okay. Thank you. I will.
Allow me to read the questions in the chat, and there's some people are raising their hands. There is a
Sure.
question by Muad Al Omari. What was the best accuracy percentage based on the applications for the LiDAR?
What was the best
I think,
accuracy?
okay, yeah. He said, what was the best accuracy percentages based on the applications?
So this is a predefined question. So you can tell, okay, for example, you say human monitoring or human activity recognition. Are you going to maybe differentiate between fingers? So it depends. In this one, you need like higher accuracy. And I'm not sure if regular LiDAR will do it. OS0, I think, can do it because this is like more than 2 million points per time. If you differentiate between, let's say, a human versus a chair, then you need less accuracy, right? If you differentiate between head and hand, maybe you need a medium accuracy. So
What
it
about
depends.
the body signals? How do you differentiate between ECG and breathing, for example? That the signal that come back or reflected back to you, how do you like image that as a breathing when you talked about the breathing?
So breathing, we did this testing with the chest. If the chest is moving, this means like there's like some movement, and we get like the centroid of the chest after doing this filtering. And then if there is a moving with the chest, then we assume there is a breathing. I know this is like a very basic thing.
ECG signal might overlap actually there.
Yeah,
You
but
just,
that one is like you have to plug it in the human, right?
so you don't like
This is
track
contact.
signal.
It's contact.
The signal. It's not about the signal. It's about the chest movement.
Yeah, but that one is contact. However, LiDAR is contactless.
Okay. Okay.
And you can sit in the room, like in the chair, you breathe, and LiDAR will just like get your breaths. However, in that one, you have to connect your whatever, I'm not sure what you call it. You have to connect it, and then with a machine, you cannot even move. You have to carry with you the other machine. Even if you go to the restroom, you will just maybe disconnect it or take it with you. However, LiDAR can be even placed in the restroom. And we are doing many good things with it, like for humans, and do kind of reporting, even my students, like how many times you go to restroom and how many times you spend in the restroom, how much time you spend in the restroom. So we develop some kind of reports that we can give at the end of the day. So it's kind of an application that you have in your phone. At the end of the day, you tell you, okay, you went 3 times to the restroom and you spend maybe this amount of time. And this is very good and useful for medical applications.
There's more questions actually, Dr. Ahmed. What about the cost-wise aspect for using LiDAR instead of the camera? This question is by Muhammad Al Ibrahim. Hey.
Yeah, this is a good question, and I can tell. Generally speaking, LiDAR is more expensive. Generally speaking.
Yes.
However, we can also like find cheap LiDARs that they can do 3D human detection with a few $100s. The LiDARs that I have in my lab, it range from $10,000. The OS0, this one is like more than $10,000. to $400 or $300, the mid-40. And, you know, because I used OS0 for different applications for many things. So I need like very high accuracy or very high resolution sometimes. But if you just consider regular resolution, there are some cheap LiDARs. And again, you know, this LiDAR technology is going to grow. It's going to grow for sure. I mean, even like here in the United States, they spend now billions of dollars on LiDAR technology recently. This means that we are going to get cheap LiDARs in the future. I know the Oster company and Velodyne company, they merged together now. These like two main companies in LiDAR here in the United States. So they merged together. Now they become like one company. And maybe this will be good. I'm not sure, good or bad, but maybe this is good like in terms of the pricing. If they just like having these kind of technologies together, comes together. So generally speaking, LiDAR is more expensive. Yes. However, camera is 2D, this is 3D. However, this is illumination, give you like illumination. Like even if a patient is sleeping at night, you know, I don't like sleep with a light. So turn off the lights. Even with that, you can still detect the human, where camera not. So there just need to include some other advantages of the LiDAR compared to the camera.
Nice. Generally question by Muad Al-Omari in terms of accuracy and notification. I don't know what does he mean by that. In general, how does LiDAR go through accuracy and notifications?
Notification, what does this mean?
I don't know. I mean, Muad Al-Omari, are you there? Okay, let's actually receive questions from Lean Hazem. She's raising her hand.
Okay.
Lean, go ahead.
Okay. I'm Lynn Hazem. I'm a biomedical engineering student, and I am my first year. My third year actually. My question is like this is my first time hearing about the LiDAR actually, but the question I have two questions actually. Can we use LiDAR in military like drops? And if it is so, how can go to the far spaces or distances, and it can be affected from the weather and difficult environments or different environments in different like like different spaces around the world like this. And my second question is it LiDAR like study the just the human actions, not the organs inside the human body? And that's all my questions.
Thank you. Let me start with the second question. So first, it's like a line of sight technology, similar to the camera. It's line of sight technology. This means it can study whatever you can see in your eyes. Okay, somehow similar. So it's like line of sight. If there's an obstacle, then LiDAR cannot see after that obstacle. So first, I mean, I'm not sure if human organs or something inside the body or not, but if there's any movement, outside movement, then LiDAR can study, even like human moving to the car, pedestrian, and so on. For the first part of the question, if I understand that correctly, you are asking about having this military application. Am I correct?
True.
Military application.
Yes, the military application, yes, in different like spaces. If it is, we use it in drops like this.
Yeah, actually, we are submitting many funding proposals to Department of Defense here in the United States and proposing this as a kind of a solution. Yes, there are many applications, and not just only LiDAR. I mean, why not integrating camera with LiDAR? So LiDAR can give benefits, camera will give another benefits, and then integrate them together. Similar to the test that I'm doing now in the lab, having this connect like depth sensor or depth camera. And combining this with a LiDAR. So we get this benefit, that benefit. LiDAR has many advantages over the camera. So like optical illusion and so on. Even if there's like, it's affected by the weather condition. The camera as well affected by the weather condition. If it is a fog, you'll not be able maybe to see. So what I'm saying that I'm not eliminating the role of the camera, but for military application, integrating LiDAR and camera can be very useful.
Nice.
Yeah.
Okay, another question from Lina Raed.
Thank you, Dr. Ahmed, and thank you, Dr. Yusra, for this incredible lecture. I would ask you about the LiDAR in the introduction. You said LiDAR can detect gases, unseen gases. Can I use LiDAR to detect unseen gases in explosive before it's bomb? It is accurate to use to detect gases, unseen gases.
Now, this LiDAR, you can use, first of all, for gases in general. This is CO2, CO2 gas, and we will be able to get it, okay? Smoke or CO2 gas. Now, the question, LiDAR will not eliminate the air. There's some air quality sensors, and these will give you like very good measurements, and even precise measurements, maybe better than LiDAR in some cases. However, these sensors will tell you, okay, there is a gas. Detect gases. Okay, there is a gas here, and will not tell you, maybe tell you about the information, a little bit about the concentration of the gases, but will not give you a map that will give you the concentration of the gases. The concentration as a map, so you can tell, okay, this gas coming from here. Because that one is based, as far as I know, for the air quality sensors, based on readings. It will just give you readings and will tell you, okay, there's some gas readings. Will just give you like kind of a level, reading levels. However, LiDAR will just give you a map. And in that map, you can tell, okay, this gas is coming from here. And you can go and maybe do actions to prevent any bombing or something, explosions. But what I'm saying that this 3D mapping will be helpful. There are some advanced air quality sensors, people from the environmental engineering here, working on advancing, even from the hardware perspective, advancing or modifying the current air quality sensor to make it like more precise. And LiDAR can reach up, maybe, as I said, like to particular matter 0.5. Below that, I'm not sure if it will detect, so we have to test that. I'm not sure, but it will give you some maps for certain gases. And again, why? Because we need like to see the particles, the gas particle. If it's like this gas particle is like kind of, more than a certain threshold, again, based on the LiDAR sensor, based on the specifications of the LiDAR. If it is above certain threshold, then LiDAR can detect. If it is less than certain threshold, maybe the LiDAR cannot detect.
What about the speed? How fast it can detect?
Oh, this is very fast. I mean, this is laser technology, so it will be very fast. It will be very fast. It will just create a real-time mapping, as I maybe have at the end of this slide here. It will just give you something like that.
Mm-hmm.
Real-time map.
Nice.
And even the air quality sensor will give you real-time readings, I can say.
Okay, there's one more question from Muad Al-Umari.
If I may interrupt, just a question related to what you were talking about. I mean, like in terms of gases, it's more like it gives you the location where there is like that concentrated gas is. And like, would that work on different types of gases, or there are just certain types?
Yeah. So this is a good question. Again, what we look about two things about the gases: concentration, how much the gases is concentrate, and the particle size. Now, I'm not expert. I'm not in environmental engineering. I'm computer engineering person or AA. But what I'm saying that if there is a particular size, the particle size greater than certain threshold, based on each LiDAR specification, it will detect it. And also, if there is a concentration of gases, it will also detect them. So the concentration, we look to the concentration, and we look to the particle size. Okay, of these two things, yeah, we can.
Okay,
but yeah, this is interesting. I mean, I did that because we have experimental lab. I said, okay, why not like let's go and test that in our experimental lab. I never worked on it. I'm not like even an environmental person, but this is kind of like interesting application to take it out of my domain. And since we have this experimental lab, experimental mind in the university, so I said, okay, to my students, let's go and try to test it. And even we tested with a powder. First, we just get a baby powder and then try to test that on the baby powder. And then it worked. It worked perfectly, And then after that, I said, okay, now let's go and test that inside the mine.
you know, like that question came into my mind because usually in our houses we like to have, you know, smoke detectors, gas detectors, like, you know, CO2 is one of the gases and CO1, for example. That's why I asked, like, would it be able to detect like these certain types of gases? So
Yes, sure.
thank you.
Thanks.
Okay, Muad, there's one more question. We're sorry, actually, there's so many questions.
No, ask as many questions as you want.
Thank you. Muad, go
Please.
ahead, please.
Yeah, do you hear me?
Yes.
Yeah, first of all, thank you, Dr. Ahmed, and thank you, Dr. Yusra, for this invitation. I really appreciate the information and the technical information we are getting from it. In my previous question, Dr. Ahmed, what I mean about the recognition and the accuracy of the detection for the different experimental theoretical data you did it. So I installed the LiDAR 10 years back, to be honest with you, in my application in the transportation field. So I install it to detect the vehicles, to detect even though the pedestrians. And we reached to a very good percentages, which is 99.9 in terms of detection and recognition. Other applications, what you highlighted as detection, like the humans, the breath of the human, the percentages you get it in terms of detection and recognition at the same time.
Yeah. So actually here's yeah, thank you very much for this question. So here's what we get for breathing. You know, breathing is new to the LiDAR. It's not like, you know, like this, you know, for different scenarios. So we did like different scenarios from different angles. You know, if you are the front of the LiDAR is different than if you are in an angle with a LiDAR, because this chest movement will be different, or the centroid, finding this centroid of chest movement will be different. And if it is like, you know, we get like 100%, almost 100% if you are just in front of this LiDAR. However, if you are with an angle, now this percentage will just go down. So if you are with an angle, we get like 78% or 93%. Again, depends on the angle, or 73%. It depends on the angle that you are facing with the LiDAR. Okay. So this is in terms of the breathing. In terms of the breathing, this kind of the percentage that we get. For the arms, I mean, I did not include the body part segmentation, the whole thing. I just include the arm segmentation. And for the arm segmentations, we got also accuracy. Like, you know, we use like confusion matrix, you know, it's like well known, and we get like accuracy for the arm segmentation around 91%. You know,
another question, Dr. Ahmed.
Sure.
How safe is this beams on humans?
Yeah, this is a very nice question, and this is I'm not sure if I put it in the slide, but I did not mention that. So here, yes, let me just come over. Okay, so here they're trying to follow the some certain requirements, okay, standard safety requirements, and this is kind of, you know, standard safety requirements, IEC, which is like safety for laser products, and these are safe. These are safe, and this is why we use these two wavelengths, because they are safe, and this kind of like safety things that we are using. So it's different than the laser, the non-safety laser technology. You know, like if you talk about FSO, free space optics, I'm not sure if you are familiar doing wireless. This something like called free space optics. This is like maybe not safe for a human, and this is why they are trying to use it on top of the building, or maybe from UAVs to UAVs, instead of using it like in indoor environments. But these are safety to humans.
Nice.
It's eye safety. We look to the eye safety mainly, not the body most likely. But yeah, these are safety. And even though I think the one that penetrates like 500 nanometer, I'm not sure, but I think that one as well. I don't have it, but that one also may be safe.
I believe it is something a little bit with the same topic, but I know the IEEE or the IEC. I read it long time back. The safety of the laser products or any wavelength of, let us say, waves. So normally, once they are doing the safety notes, they are saying if this waves applied on the object for a certain period, let us say for 1 minute or 2 minutes, if there's something like this with this safety notes, or it is just a safe, and we are referring back to the ICE rules 6825.
Yeah. These two are safe. Okay, so these two
Okay.
wavelengths are safe, based on what we read, and also based on whatever like we have. So these are safe, and we even test that. So I'm pretty sure that these two wavelengths.
Last but not least, Dr. Ahmed, sorry, I talk many times, and I need to keep space for the others.
Okay.
Recently, in the last, let us say, I'm speaking commercial-wise, I saw that many factories, many manufacturers, they are mixing many sensors together, like what you are saying, to mix the camera with the laser. Some of them, they are mixing the laser with the radio microwave and the IR. They are making 3 sensor technology together, and they are doing the detection based on it, based on the application, in order to maximize the accuracy detection and the accuracy of the recognition. Did you mix anything with the laser rather than the last note you highlighted that you are mixing the camera with the laser and doing some research on it? And thank you.
Yeah, thank you. So the only thing that I'm trying to integrate is the depth sensors with LiDAR, and this Microsoft Connect. I'm not sure if you are familiar with, but it's like
what's the technology of the depth sensor, Dr. Ahmed?
It's camera. It's camera.
It's camera. The camera.
It will give you. It's not RGB, not RGB. Red, green, blue.
Blue, I know. Yeah.
The regular one. It's not RGB camera. It's a depth sensor. It means that it will give you XYZ, or maybe XY, not XYZ. It will give you the location. However, again, it suffers from all these kind of cameras issues. So we trying to integrate this depth sensor with LiDAR. So depth sensor, the Microsoft Connect, one of the depth sensors, it will give you the one that we have version 2, I think. It will give you the infrared. It will give you like even RGB camera, and also it will give you the depth data. So we integrating all these 3 together with the LiDAR for different applications. So we're not talking about the privacy application now.
What do you think about the thermal camera, Dr. Ahmed?
Yeah, thermal camera, it is like widely.
Because it will add a value to the laser, in my point of view.
Yeah.
Since the laser, if there is an object, it will stuck and return back. But the thermal camera, maybe it will detect the temperature after that object. It's just an idea.
So thermal camera, it is also like there, but still it's a camera, it suffers from several regular camera issues. And it is like, by the way, affected like, environmental effect, like even maybe sometimes more than the LiDAR, it will get like kind of or something. So it has like some suffering from.
Audience who are asking questions in the chat, I'm sorry.
No problem.
Did you study, Muhammad is asking, did you study the latency of the LiDAR versus the camera?
There is no latency, as far as I know, for the camera. So basically the light intensity, light intensity. So for the light intensity, we just get it from the light. There is no light intensity for the camera. No, camera will give you 2D, regular camera.
True.
Lee
asking, how can as a student use LiDAR in many projects that you mentioned before if it's so expensive?
And how to use them? I mean, I am a professor. I have like many students. I have many students that are working in different projects.
Funded
So you
project.
can just need, I suggest like to focus on one project, you know, as a student.
Uh-huh.
And just focus on one project. Try to maybe search for them. And for sure, I mean, she's welcome to email me. I will just give her some directions if she wants. But yeah, focus on one project and
I think
be
she
expert on it.
thinks it's very expensive for her as a student to use LiDAR in many projects.
Oh, it's expensive. Okay, expensive in terms of money. Okay.
Yeah, she is
So,
like just
you
kind
may-
of asking a general question just to criticize that how expensive LiDAR is.
I mean, she can try maybe basic lidars online. I mean, there's like some lidars $200
Mm.
and 200 dinar, you know, and it's online 3D lidars, indoor environment, can get it from any website, and you know, even cheaper than a phone, you know. So it's doable. I think it's like similar to the camera. You can get, or you can start with a toy lidar. It's not a toy lidar, but actually it's good lidar to start with, and
Yeah.
with a small amount of money.
Interesting. Final question by Dr. Isra.
Sure.
Dr. Isra, go ahead.
Assalamu alaikum. Okay, so my question is a bit technical. It's about the pre-processing that you explained, and like you in the two different slides, you talked about pre-processing using clustering, and then you talked about clustering again. Yeah, in this slide, you talked about as a step of data filtering, you will be using clustering techniques to pre-process the data. And then in another slide later on, you also talked about using clustering through, I think, neural networks. You use neural networks in that. So I just wanted to
These
know,
ones?
For vector machine. Mhm.
These
you,
ones?
I mean, it seems in here like you used k-means in this case,
mean,
and it was
I did-
another where you use space theory clustering
yeah,
graph theory.
yeah. That one is not for, yeah, I know. Like in the other project. Okay, go ahead.
Yeah, it just I wanted to understand, like, are these two different things that you're doing, or they are related?
Yeah, so no, here's the thing. I mean, I use this like neural network, or we call like this waveguide, generative network, not for clustering itself, but we use this to find the best link in order to transmit the data over time. Here, you can look to here. So that one's like, you know, when we talk about the k-mean, or we talk about
Okay.
the density-based clustering, that one to cluster the objects. Okay. But here we use this as a graph. We implement this as a graph, you know, neural network, not just to cluster the object, but rather to find the best, I can say, trajectory, or the best transmission links between the
Oh,
two.
the shortest path link.
I mean, yeah, they call it in the literature salesman problem. Yeah,
Okay.
imagine that a salesman, he just moved to different cities. And
What
he
would be the
needs to
shortest
stop.
path? Isn't that
Yes, it is short. Yes, exactly.
Oh.
It's a shortest path problem that we consider the channel model, and here we use millimeter wave. I did not explain it in details, but you know, because I was fast. But here we use millimeter wave, and these numbers represent the location, the altitude. Sorry, they represent the altitude of each UAVs, and this kind represents also the lengths. So this means that if this UAV here at altitude 44 meters get mapping, just need to transmit all these, I mean, these areas. I mean, it will be transmitted to all other
we
UAVs.
transmit them all together?
Yes.
Okay. Thank you.
Okay.
Yep.
One last question from Lena. It's good. I think she's confirming. Is it good to integrate LiDAR using machine learning to improve a 3D printed machine, right?
To improve what? To improve?
You can read the chat if you want, but I think she's confirming the point. It is good to integrate LiDAR using machine learning to improve a 3D printed machine. I don't know what she means by that.
Yeah, integrate. I think what she's referring to is like having LiDAR inside the 3D printer.
Is that what you mean?
Yes, exactly. Yes.
Huh.
Using LiDAR inside the 3D printed machine to improve detection the 3D model?
So printed machine, generally speaking, 3D printers to print the 3D objects. And for example, the one that I have in the lab, we have a camera. And in that camera, we can just to see the printing, how the printing is going. I mean, so we have camera inside the printer to see how is the printing. However, you know, this is like very short range, by the way. It's like, you know, small range, like centimeters. And having, I don't know, like how to place LiDAR there.
That would be a very expensive choice, actually. So there's like.
And what's the benefit of that? I mean, why I need to place it? To see how the object is printing? I'm not sure. I don't think so. This is something good. I mean, to have to improve. I mean, you just like, you know, have this a picture or just you draw it and then you send it to the 3D printer. The printer will just like do it.
And this will make the 3D printer actually more expensive, and no need to make it this expensive, right? Adding LiDAR.
Yeah, it will not get. I'm
Okay.
not sure there's something else.
More
Maybe in
questions,
her
actually.
mind.
If
No.
there's questions,
It's not a question, Dr. Yusra. Do we have LiDAR in Jordan market? Is it easy to get it in Jordan market? Because we tried to get drone, but now it's
John has
with-
privacy concerns, but I mean, LiDAR, I think you can buy it, right?
there is
Like-
no problem. I mean,
No.
for the custom issues and because we've been tried to get a drone, but this is last year. But this year, I guess with the all issues that we have now in this area, a drone it's
For drone, you need the permission actually to use it. Yes, you need the permission.
issues. Okay, all right.
Yeah.
Okay,
We
thank
have
you.
here something called pilot certificate for drones.
Mhm.
But
Even-
no, I mean, my students usually flying the UAVs, no problem. So you need this pilot if you are going to publish this data. So it's something different here in US. And it's $5, I mean, to get this pilot. So
No,
I think it's different things in Jordan. You may ask,
Yes.
not sure, your research
Especially
office.
now, Dr. Ahmed, especially now. Okay.
Yeah, maybe you ask your research office in the university if they can help. I don't know. Actually, I don't have information.
Okay.
For the LiDAR or UAV.
That was very great and interesting, exciting, very informative talk, actually. It was very useful for everybody. And I really myself enjoyed everything, the way that you presented the talk and the information and how rich the information were. Thanks a lot for your contribution in our research series. And thanks everybody for attending this lecture and like adding your suggestions and the questions. Thanks a lot. يعطيكم العافية.
Thank you very much for organizing this
You are more than
presentation, and also for you, Dr. Isra, for the rest of the team. Yeah, I'm here anytime, any help, please visit my website. And if you have like any mutual interest, I'll be very happy to collaborate with you.
إن شاء الله إن شاء الله. Thanks a lot.
Thank you. الله يعطيك العافية.
ويعطيكم العافية جميعا. تصبحون على خير. السلام عليكم.
Bye bye.
السلام عليكم.